We looked at limits from the perspective of graphing, but we can also see them using algebraic techniques. We're going to calculate limits using limit laws, and unfortunately, I've got to fill the screen with text. These are a bunch of limit laws. I know it's a lot to look at, but if you look over here, what you see is sum and difference, constant, multiple, product, quotient, power, root, constant, identity. And what these limit laws are basically saying is that you can do what you think you can do with limits. That is, if I'm finding the limit as x approaches a of the sum of two functions, then that's the same thing as finding the limit separately and then adding the results together or subtracting them. If I have a product of two functions, then I can multiply before finding the limit, or I can find the limit before I multiply, provided that both the functions f and g have limits as x approaches a. These aren't to be memorized, I wouldn't say, but they are the basis of some things that we'll do, but we'll just touch on them and then move on, essentially. And let's just move on to an exercise here. Evaluate the limit and justify each step using or indicating the appropriate limit law. And it's the limit as x approaches 1 of x to the fourth minus 3x times the quantity x squared plus 5x plus 3. Right off the bat, I see what I have is a product, right? It's a product of a binomial and a trinomial. And so the limit law I want to apply is going to be the product law, which says that I can break apart a product, the limit of a product, into a product of limits, essentially. And so we'll say that this is equal to the limit as x approaches negative 1 of x to the fourth minus 3x times the limit as x approaches negative 1. Yeah, these are kind of tedious to write out, as you can see, of x squared plus 5x plus 3. And what we used was a product law. And then we keep going. I'd like to, what I'd eventually like to be able to do is I'd like to get it to the point where I can just apply the limit of a constant and the identity limit. And in order to do that, we'll just keep applying the limit to like terms and move on from there. So we've got the limit as x approaches 1 of x to the fourth minus the limit as x approaches, it's x approaches negative 1 of 3x. All of that time, I guess I only need parentheses here, times the limit as x approaches negative 1 of x squared plus the limit as x approaches negative 1 of 5x plus the limit as x approaches negative 1 of 3. All of that's multiplied together. And what we used there were sum and difference laws. Now, some textbooks like number these, limit law number 1, limit law number 2, and etc. And if that's the case and you're doing homework for me, then you would identify limit law number 3 or limit law number 1 and 2. Now, when I have the limit as x approaches negative 1 of x to the fourth, that's the same thing as negative 1 to the fourth power because of a power law. And here f of x is just x. And if I have the limit of a function to a power, then it's the same thing as finding the limit first and then taking that to a power. Oh, you know what? I skipped ahead. Oh, I'm not even going to edit that out. I'm going to leave it in. Because what we should have is the limit as x approaches negative 1 of x, that thing to the fourth power. All right, minus, now we're going to pull out a 3 here, the limit as x approaches negative 1 of x, and then all of that is the first term. Now I'll just write out the rest of these. And when we took, when we wrote the limit as x approaches negative 1 of x to the fourth power, that was a power law. When we pulled the 3 outside of the limit as x approaches negative 1 of 3x and wrote it as 3 times the limit as x approaches negative 1 of x, that was a constant multiple law. We again used a power law on x squared. a constant multiple law on 5x. And then as x approaches -1, 3 is 3, right? The limit of 3 is always 3. It doesn't matter. And that is, I'm calling the limit of a constant. What's going to happen now is I'm going to substitute -1 in place of x everywhere I see it. And that's the one where I'm using what I call the identity limit. So the result of that is -1 to the fourth times -3 times -1 to the fourth minus 3 times -1. That difference times the quantity -1 squared plus 5 times -1 plus 3. And in all cases there we used an identity limit. And then finally this is going to turn out to be 1 plus 3 times 1 minus 5 plus 3, which equals -4. At this point, you if you've been following along, you see that what really happened is we basically took this -1 and substituted everywhere we saw an x, and then just evaluated the expression. And yeah, that's exactly what we did. These limit laws are what justify us being able to do that. Oh, I guess if I'm going to be consistent, I should put parentheses around all of these. So these limit laws allow us to find a limit by direct substitution if possible.